And welcome back, students, as we talk about our next type of linked list, which is that of a doubly linked list. Up to this, we've looked at single linked lists, but now we're going to look at the double version. All right, doubly linked list. So, an ordinary linked list, like the ones that we've been talking about, pretty much allow us to move down the list in one direction only. Pretty much just follow the links, go from point A to point B to point B to point C, etc. Well, a doubly linked list also has a link that's a reference to the next node and a reference to the previous node. So in our old version of linked list, like we would just have this down arrow here. But now with a doubly linked list, not only do we have the arrow that points to the next node, we also have a link that will point us back to the previous node. Now in some cases, the link to the previous node can simplify our code. For example, we no longer need to have a previous instance variable to remember the node that links back to the current position. The node class for a doubly linked list can begin as follows. Private class two-way node, private string item, private two-way node previous, private two-way node next, yada yada yada. The constructors and some of the methods within the doubly linked list class will require some changes from what we did with single linked lists in their definitions in order to accommodate that extra link. Now, the major changes, therefore, are to the methods that either add or delete nodes. So to make our code a little bit cleaner, we are going to add a new constructor that sets the previous and the next nodes. Public two-way node, string new item, two-way node, previous node, two-way node, next node, item is equal to new item, next is equal to next node, and previous is equal to previous node. All right, so here's an example of our first linked list process. So let's say we want to add a new two-way node to the front of the list. Well, this requires setting links on two nodes instead of one. The general process of how we do that is kind of shown here at left. In the add to start method, we're first going to create a new two-way node. Now, because the new node will go on the front of the list, we set the previous link to null and the next link to the current head. Two-way node, new head equals new two-way node, item, comma null, comma head. And if we look at our diagram here, we can kind of see that here's our existing list. Head nodes pointing to coat. All right, you also have the previous nodes pointing back, and the next links are pointing forward. So if we want to create a new two-way node linked to coat, all right, new two-way node, just like we saw before, item, comma null, comma head. So right here we have coat being inserted in. All right, this is, of course, where the head was. We also have our new head here. So what we're going to do is we're going to set a backward link and set the new head. So head.previous is equal to new head. Head is equal to new head. Next, we must set the previous link on the old head node to reference the new head, which we just saw in our diagram. We can do this by setting head.previous is equal to new head, but we must take care to ensure that head is not null. In other words, the list is not empty. Because if it's empty, well, a little harder to work with things. Finally, we can set head to new head. So if head is not null, head.previous is equal to new head. Otherwise, we're going to say that the head is equal to new head. All right, so we just looked at adding a node to the front, but what about deleting a node? Well, deleting a node from the double linked list also requires updating the reference on both sides of the nodes to delete, because remember you have the link that points to the next and a link that points to previous. Now, thanks to the backward link, there's no need for an instance variable to keep track of the previous node in the list, as was required with our single linked list. The general process of deleting a node is referenced by the position shown at right. You'll note, though, that in some cases, things must be handled separately, such as deleting a node from the beginning or the end of the list, which is why we just looked at the beginning one just a second ago. So here I have an existing list with an iterator referencing shoes. So I'm going to bypass the shoes node from the next length of the previous mode, position.previous.next equals position.next. Then you'll see that we are going to bypass the shoes node from the previous length of the next node and move the position off the deleted node. So position.next.previous equals position.previous, position equals position.next. So here we go, we're going to delete that out. So we're getting rid of this position is now pointing to socks. And this might look a little confusing again. So again, it's redrawn for clarity. You can see head points to coat. We have our previous link pointing back. This is pointing to socks, and position is pointing to socks. All right, now that was deletion, so let's do insertion. All right, in this case, we're going to insert the new node at the front of the iterator, referenced by the position. You'll also note there are special cases for the insert routine when inserting to the front or adding to the end of the list, kind of like we saw with our previous code. Only the general case of inserting between two existing nodes is shown here on our diagram. Now, a complete example of the doubly linked list, of course, is shown within the doubly linked list class within our class materials. Use of the doubly linked list is virtually identical to use of a singly linked list. All right, so it's kind of one thing to keep in mind. Other than this other step that we got here with the referencing the previous link, a lot of the functions are still the same from what we did with a single linked list. Now, the doubly linked list demo demonstrates the addition, deletion, and insertion of the doubly linked list. So here, of course, if we look at our diagram, here's our existing list. We're going to create a new two-way node with a previous linked coat and next to shoes. So here we go. So two-way temp node, temp equals new two-way node, new data position.previous position. You notice that we're adding in shirt. Shirt, of course, is referenced right here. I'm going to set the next link from coat to the new node of shirt. Position.previous.next equals temp. Boom. Then we're going to set the previous link from shoes to the new node of shirt. Boom, boom, boom. Position.previous.temp. So you see this arrow, which was pointing to coat before, now points to shirt. All right. And of course, if it was all said and done when you're done with this, because it was pretty much would look like this when you're done, just shirt would be moved up inside of here. All right, and that's going to wrap up that side. Let me just pop over to Eclipse real quick to kind of give you an idea of that doubly linked list. So in here, you'll see that there is our two-way node right here with its different constructors and stuff like that. So here's our item, next, and previous, all set to null. Here's the public class doubly linked iterator. And of course, here's our demo, which if we run that code, you can see that we have very similar output to like what we saw before. Coat, orange shoes, coat, orange shoes, coat, socks, orange shoes. All right, now there's one thing I just wanted to kind of show you real quick, and there's a whole piece about this in the course materials. So I'm just going to go throw it in here real quick. And that is, of course, the linked list class that already exists within Java. So there is a class within Java known as the linked list class. Now, you might have come across this on your own, or you may not even know about it, but here you go. So I'm just going to set this up real quick. String args. All right. So to get the linked list class, all I'm going to do is I'm going to just import from java.util, again, java.util, and I can actually just import the linked list class. All right. And that'll allow me to make linked lists. And they construct very similar to like array lists and stuff like that. And again, that's in the class materials. Now, the reason why I'm bringing this up, and we haven't talked about before, it's like, oh, wait, there's linked lists already. I don't have to create my own linked list. Well, there's kind of two main reasons. Reason number one is this is a pre-made class. If you wanted to add any additional methods to your linked list, being able to make your own class is going to be a little bit more advantageous. However, that being said, the linked list class that exists within java.util, for most of your purposes, is probably going to have what you need, like adding of a node, deleting of a node, all that kind of stuff that we've been talking about will be in the linked list class. Now, part of the reason we haven't mentioned it before now is that the linked list class that exists within java.util is a doubly linked list. So if you remember when we started off, we talked about singly linked lists and not doubly linked lists. So it would have been a disservice to you learning first about linked lists and all the different structure elements and the different pieces with nodes and stuff like that to jump right into this linked list structure. So it's better for us to kind of learn about those pieces first and then jump into this one. So this is going to be something that you'll be able to see within the class materials. There's a whole bunch of resources on there so that way you can kind of pull that in case you say, hey, I want to use this because this sounds a lot better than trying to make all that code and copy and paste it around and stuff like that. By all means, use this. In fact, I recommend that you can use this if you're comfortable using it. There's documentation, there's examples out there that show you how to use this class. So it's, again, very handy to have, but if you ever need to do your own like methods or anything like that, you can always come back to making something like this where you'll have your own links and nodes and everything like that. So with that being said, folks, that's about all I have for you today, and I will see you next time.